Okay, so we're going to move on to chapter 9. So kind of as you've seen, everything that we do builds on what we've done before, and this is no exception, okay? So don't get in the mindset of you finish the homework, you get the right answers, and then you let it all fall out of your brain. So we have to keep retaining everything we've learned because it's all building, and this is going to build on chapter 8, okay? So don't forget what we've done before, or else you'd be starting over again. Okay, so chapter 9 is about hypothesis tests. Hypothesis tests. So let's talk about what that's about. So section 1 is just to get the idea of it. So what is it about? It's not very math intensive, but more kind of let's learn what it is. So we got some definitions here. The null hypothesis. Okay, the null hypothesis is just some hypothesis to be tested. It's like a conjecture. It's like we think maybe this is true. Okay, we think maybe this is true, and we're going to test it statistically. We're going to test it. So we use H naught to represent the null hypothesis. Okay, null and 0. That's how you can remember it. Null is like 0. Okay, and then there's going to be, for every null hypothesis, you're going to have an alternative hypothesis. So this is the hypothesis to be considered as an alternative. So if not the null hypothesis, then what? And that's the alternative hypothesis. And that's HA, A for alternative. So this is a little vague, and it'll make sense very quickly when we start getting into actually doing it. Okay? But it's like there's this idea that we have, the null hypothesis. Is such and such true? The alternative hypothesis would be, okay, the null hypothesis is not true, so therefore that we conclude this. Okay? So a hypothesis test, the problem in a hypothesis test is to decide whether the null hypothesis should be rejected in favor of the alternative. So the test is we're going to reject the null hypothesis or not reject it. Okay? So it's a little bit strange because we're not going to say the hypothesis test is about whether or not we reject the hypothesis. It's not about whether or not we accept it. Okay? It's about whether we reject it or not. So it's a little, so we'll see that in examples, okay? All right, so here's an example. You don't want to write this down word for word. And we'll see, we're going to be kind of working through this example throughout class. So just kind of listen. So it says, in the pretzel packaging example, a null hypothesis must be the mean weight of all bags of pretzels packaged equals the advertised weight of 454. So this is very common for hypothesis testing. Products will advertise a certain quality about their product. So in this case, they're putting on their pretzel bag that there's 454 grams of pretzels. Okay, but the machine that puts the pretzels in the bag is going to have some margin of error, right? Every bag is not going to be exactly this. So the null hypothesis might be that the mean weight is indeed 454 grams. Okay? And so then the alternative would be that the mean weight is not. It differs from 454. Okay? So this is an example. And so the test would be to either reject or not reject the null hypothesis. So here's kind of the weird thing. If we don't reject the null hypothesis, it's not the same thing as saying that we conclude that the mean weight is 454. All we're saying is that we don't rule it out. So we're saying it's possible. So if you don't reject the null hypothesis, you're saying it's possible that the mean weight is 454. Okay? Or we reject the null hypothesis and we say we're within some amount of confidence that the mean weight is not 454. Okay, so that's a little bit counterintuitive, but we'll keep talking about it. All right. So hypotheses concerning the population mean mu. So this is where we're going to live, right? So there's all kinds of different hypotheses you could test, but the ones we're going to test are about what is the mean of a population, okay? And so this is kind of where we've been. If you have a sample or samples, we want to try to take the information from those samples and say, what's the population mean? We've seen that before. So now we're going to do hypothesis testing about that same thing, determining the population mean. Okay, so our null hypothesis is that the population mean is some value, like in the pretzels. The population mean, the mean weight of all bags is 454 grams, whatever it is. And this is the notation we use, okay? And so in the problems, you're going to have to recreate this notation. Okay, and then alternative hypotheses, there's three possibilities. There's three possibilities, and the first one is the one we saw in the pretzel example, that the mean is not that value. Okay, so the population mean is different from that, and this is called a two-tailed test. Okay, because it could be higher or lower. Okay, so I'll just make a quick sketch here. Oh no. Put this on, that's why. Okay, so just a real rough sketch here. So we know our normal distribution looks something like this. And so then a two-tailed test would be, oh, well, the population mean it's likely that it falls here or here, so two tails. So we're trying, so we're asking, is our population mean equal to some number? 434 grams in a pretzel bag. Okay, so the alternative would be, oh, it's significantly lower than that, or it's significantly higher than that. So that's the idea of a two-tailed test. Okay. The next positive alternative is that the population mean is less than that. So this is a left-tailed test. So we're just testing for we're only testing for that the actual, so here we're saying, is the population mean equal to this value? Well, the left-tailed test is testing, the alternative would be, no, it's significantly lower. It's significantly lower than the mean that we're starting with. Okay, and so then, of course, and so how can you remember this? So less than, you think less than, you're to the left on the scale, right? You're just left than on our variable scale. Less than would be to the left. So that's how you can kind of remember which is left and which is right. So the right tail test then would be, okay, we're gonna test to see if it's this value. The alternative is, oh no, it's significantly greater than that value. Here's our right tail. It's like, all right, so is the population mean equal to some value? The alternative is, no, it's significantly greater. It falls up here. So when you're doing a hypothesis test, you're going to have the null hypothesis, and you're going to have one of these. You're going to have one of these, okay? You're going to either be testing for just different from, less than, or greater than, or more than. So in a given hypothesis test, you'll have the null and you'll have one of these three alternatives. Any questions so far? Okay, so let's work through these together. We'll do these together. Okay, so a snack food company produces a 454-gram bag of pretzels. Although the actual net weights deviate slightly, the company insists that the mean net weight of the bags is 454. Okay, so as part of its program, the Quality Assurance Department periodically performs a hypothesis test to decide whether the packaging in the machine is working properly. That is, to decide whether the mean net weight of all bags packaged is 454. Okay, so the null hypothesis. So let's write this out. So determine the null hypothesis. Well, so we use this terminology. H naught, colon, and then we're saying, is the population mean equal to 454? There's the null hypothesis. So the alternative. So we have to pick which alternative. Is this going to be the two-tailed that is just the alternative? Is it just that it's different than this, or less than this, or greater? So we just have to read and pull it off of the information in here. Okay, so to decide whether the packaging machine is working properly, let's decide whether the mean weight of all bags packaged is 454. So, so have they mentioned anything about less than or greater than? No. So then our conclusion is that we're going to do the two-tailed. So our alternative here is that the population is not equal to 454. So this is our two-tailed hypothesis test. So in this test, it's just as bad that it's putting too many pretzels in the bag as it is not enough. So you might think that the more important thing is that in such a situation like this, like the weight of a product, you might think the important thing is that it's not too low, right? But there's nothing in there that says, all they're saying in here is it's just whether it is 454 or not. So then it would be bad for the machine to be putting too much in as well as not enough in. So that's our two tails, right? Not enough, too much. Okay? Okay, so this is just for your notes. It's not for the sheet. So why don't you just try this one for yourself. So just we're practicing setting up the notation for the test. And this is for your notes, not for the sheet. Okay? And you can talk about it and just give this one a shot here. Prices of history books. Okay, so how'd we do here? Ashlyn, did you get the null hypothesis?
Yeah.
Tell me. Okay. Mu. Null hypothesis is that the population mean is 7801. Okay? Alternative. Did you get it, Miguel?
Yeah, it's H sub A.
Mm-hmm. Agree with that? Okay. Two-tailed, left-tailed, or right-tailed? I heard right-tailed. Agree with that? Yeah, this is right-tailed. So we want to know, is it significantly higher than 78.01? And so higher, just think to the right, right? To the right. So you have that little tail where it's too far away from 78.01 to conclude, it's too far away so that you would reject the null hypothesis. Okay, any questions on this? Setting up these. Okay, so the way the book sets this up is real nice because we're getting the idea first before we get into the heavier mathematics of it. Okay, so for your blue sheets, you got 2 here to do. You can work together. I will not. So sometimes I will go over one afterwards. I'm not going to do it in this case. This is too easy. You can do it. Okay. So you're doing the same thing you just did. You're going to write out the null, the alternative, and then classify. Piece of cake. Okay, here we go. Okay, so then let's talk about testing and error types. Okay, so here's the idea behind hypothesis testing. We're going to take a sample, okay? We're going to take a sample. Okay, we're going to take a random sample for the population. If the sample data are consistent with the null, we don't reject it. That's what I was talking about before. It's not that we accept it and we can make this conclusion that, yes, the population mean is this. It's that we don't reject it. We say it's possible. It's possible that the population mean is this. Okay? If the sample data are inconsistent with the null hypothesis and supportive of an alternative hypothesis, then we reject the null in favor of the alternative. So this is how it works. It's not that we're going to conclude that the population mean is this value. It's that we're just going to not reject that and say it's possible that the population is that value, or we reject the null and we say we can conclude with some amount of significance that no, the population mean is not that value. Okay, so then there's 2 possible errors that we could make. We could reject the null hypothesis when in fact the population mean is that value. So it's possible to do that. So before we talk about errors, so remember with taking random samples, we know that it's a matter of confidence. It's not exact science, right? That's what we've been doing the last couple chapters. That if you have a random sample, we can only conclude that the population mean is a certain amount with some confidence, whether it's 90% confidence, 95% confidence. So because of that, because we can't be 100% certain, then that leaves the possibility of making these errors. Okay, we could reject the null hypothesis when in fact the population is that value, the population mean. Or the type 2 is we don't reject it when we should. Okay, so we don't reject the null hypothesis when we should. Okay, and you have to remember, you have to memorize this, what a type 1 is and what a type 2 is. Okay, you're going to have to know. Type 1 is that the hypothesis is in fact true, but we're rejecting it. We're making that error of saying it's not true when it is. And then the type 2 is we should have rejected it, but we didn't. That's a type 2 error. So here's a little chart that kind of organizes the 4 possibilities. Okay? The null hypothesis, if it's true and we don't reject, we've made the right decision, right? And if the null hypothesis is true but we reject it, we've made the type 1 error. Okay? If the null hypothesis is false and we don't reject it, we made the type 2 error. And if the null hypothesis is false and we reject it, then that's the correct decision, right? So this is a nice table that summarizes the 4 possibilities, 4 conclusions we can make in a test. And like I said, so you have to know when we say type 1 error, you're going to have to know that, right? You're going to have to know that that's when the null hypothesis is true, but our data led us to reject it, and then vice versa is our type 2 error. Okay, anybody have a question on that? And does it make sense why it's very possible to make the errors, right? That goes back to what we've been doing recently. When you take a sample, we can't know for sure what the population mean is. We can say with a degree of confidence that it's in this range, right? That's what we did. Lots of that. And that's why those errors could occur. Because we can't know exactly. We can only get that confidence interval. Okay, so we'll do this together. So here's the Pretzel example again. So we had our null hypothesis was that the population means, or all bags have a mean weight of 454 grams. The alternative hypothesis that they don't. Okay, the machine is not working properly. Okay, so explain what each of the following would mean in this context, right? So the whole point is not that we regurgitate what was on the previous page, but now we apply it to this example. So let's put that in this context. So why don't you, with your partner, verbally explain what a type 1 error would be relative to the pretzels. What would a type 2 error be relative to the weights of the pretzels? Okay? And what would a correct decision look like? Okay? So talk. So with your partner, just talk out what a type 1 error would be, what a type 2 error would be, and what a correct decision might look like. But it's about the pretzels and the weight of the bags. Okay? Go, talk about it. No, this is not for the sheet. So it'll say for the example for the sheet. All right? So this is no, not writing it down. Okay, don't go on to this. Just do A, B, and C. Don't do D and E yet. Just do the first A, B, and C. Okay. So Danny, can you explain what a type 1 error would be in this case?
Type 1 would be saying that the H naught isn't true when it really is.
Okay, so talk to me about pretzels. Talk to me about the weights of the pretzels.
So we're saying that it's not giving us 454 grams, but it really is.
Okay, so the result of our test would say that the mean is not or significantly far enough away from 454 that we would reject the null hypothesis, but in fact the mean weight is 454 or close to that. That's a type 1 error. All right, what's the type 2 error? Ninos. Talk to me about pretzels.
So the conclusion would be that the pretzels are not 454.
Okay.
We didn't reject the null hypothesis when we did it.
Okay, so the results of the test led us to do what?
That the
The mean
mean was not 454.
was not 454. That's what was true or what the test we did? So this is the result. So an error means that the result of the test and what's actually true don't match. So there's two things, right? There's two things. When you have an error, you have the result of the test, and then you have what the truth is, right? And those don't match. That's when we get an error. So, want to try again?
Sure. All right, I'm a little confused. Type 2, you said we don't reject the null hypothesis.
We don't reject. So as a result of the study that we did with the sample, we don't reject the null hypothesis. So what would that mean? If we don't reject the null hypothesis, we're saying what about the pretzels?
We think it's 400.
Right. That the mean is or close, 454 or close. Okay. But what was actually true? Right. But the truth is that the actual mean, the population mean of the bags is not 454. That's a type 2 error. Okay? How could we have a correct decision? How could we have a correct decision? Yvonne.
The actual answer is the mean is 454, and we don't reject them.
Good. So that's one way we could do it. So if the actual mean in the bags is 454 and we don't reject the null hypothesis, then how else could we do it?
The mean of the bags isn't 454,
Right. And we do reject. Right. So the mean is not 454. It's significantly further away from 454, and we do reject. Those are the two correct decisions. Okay. So now go ahead and now suppose the results lead to rejection of the null hypothesis. Conclusion that the mean weight of a bag is not 454. Classify that conclusion by error type or correct decision. So if the mean weight is, in fact, 454, is that a correct decision or an error? So we're rejecting. So we do the test, we reject the null hypothesis. The mean weight is, in fact, 454. Is that error or correct decision? Error. Type 1 or type 2? They're all saying 1 over here. What do you think? Type 1 or type 2? Type 1. This would be a type 1 error. Type 1 error. Okay? The mean weight is not, in fact, not 454. Error or correct decision? Correct decision, right? We rejected the null hypothesis, and in truth, the mean weight was not 454. So that D was a type 1 error. E is a correct decision. Questions on this example? Does it make sense? So lots of ideas to keep track of, right? So that's the goal here, is the ideas, and we're practicing that. Okay, for your sheets. So I'm going to write out the setup from before over here. So that's the setup. That was the test that this is referring to in 9.7. Again, when you're writing these out, you're writing it out in the context, right? You're not just writing out the, you don't reject when you should have. No, so talk about females getting enough iron, okay? Talk about post heart rates exceeding the resting rate of 72. Last chance, any questions? Okay, we're going to go on. Okay, so significance level. So the probability of making a type 1 error, that is, we're going to reject a true null hypothesis when, so rejecting a null hypothesis when in fact it's true is called the significance level, alpha. So alpha is the probability of making the type 1 error. That's the idea. It's the probability of making the type 1 error. And then beta is the probability of making a type 2 error. And so that alpha, the probability of making a type 1 error, is what we call the significance level. Significance level. So we're about to get into an actual example where we're going to actually do a hypothesis test, crunch some numbers, and make a conclusion. All right, either reject or not reject the null hypothesis, and talk about what that means. And so this stuff comes into play here. So again, the probability of making the type 1 error is the significance level. That's alpha. The probability of making a type 2 error, then they use beta. Okay? Are we good? Okay, so we're ready to go on to the next section. So there's some different approaches to hypothesis testing. The first one we're going to do is the critical value approach. Okay? Critical value approach. And then we'll do the other approach on Wednesday. We'll do both. Actually, we'll do both on Wednesday. But we'll start with a critical value approach. So here's an example. So Jack is a golfer, and he claims that he can drive the ball from the tee. He can hit his tee shot an average of 275 yards. Okay? Jack's friend, Claire, is very skeptical. She says, no way, your average is not 275 yards. Okay, so we're gonna do a hypothesis test to see if indeed it's possible that he averages 275 yards per drive. So he hits 25 drives. He hits 25 drives, and these are the distances in yards of those 25 drives. The sample mean, right, this is our X bar. So of those 25 drives, his sample mean was 264.4. And what is this is the population standard deviation. So for just in general, for people hitting drives, we're assuming a standard deviation of 20 yards. And remember, this is what we did also when we started the confidence intervals. We said we're going to take a sample, we're going to look at the sample mean, and we're going to assume a certain population standard deviation. Remember we did that at first. So this is the same thing. When we do critical value testing, we assume what the population standard deviation is. Okay, and did we say that that is a realistic situation, or that's less realistic? What's that? No, the fact that we know the population standard deviation. So we're going to take a sample, but we know what the population standard deviation is. Is that like? What's my question? Let's see. Is it kind of contrived a little bit, or is it realistic? Remember what we said? No, it's a little bit contrived, because why would we know that, right? So really in testing, it's kind of the most realistic situation is all we have is the sample. All we have is the sample. So it's a little bit assumptive, like presumptive, to say that you know what the population standard deviation is. Why, how and why would you know that? Okay, but it just provides a way for us to get started. Okay, and then the next type of testing that we'll do, we'll say we don't know that, and that's kind of like more realistic. In the real world, we'd take a sample and we wouldn't know necessarily what the population standard deviation was. But this is a way to get started, and this follows the pattern when we did confidence intervals. It's the same thing. We kind of at first we assumed, okay, we know the standard deviation of the population. Okay, so we want to make a conclusion about this at the 5% significance level. Okay, that is alpha equals 0.05, or a 5% chance of making a type 1 error. And what would a type 1 error in this case look like? A type 1 error would look like what? Who can explain what a type 1 error would be in this situation? Saying that he can't hit it that far when he actually can. Agree or not? That's what it is, right? We're going to reject the null hypothesis. Also, we should. So let's talk about. Yeah, that was exactly right. So we're going to state the null and alternative hypothesis, discuss the logic, and I kind of jumped the gun on that. That's what the question I just asked. Then we want to obtain a precise criterion for deciding whether to reject the null in favor of the alternative, and then we want to apply the criterion in part C to the sample data and state the conclusion. So this is kind of what we want to do to conduct this test. We want to set up our hypotheses, describe kind of what our logic's going to be behind it, and then do the math and make our conclusion. So how about you guys write down This is just for your notes, not for your sheet. Write down the null and alternative hypotheses, and then we'll discuss the logic. So can you write down the null and alternative hypotheses? Well, the null will always be equals, right? Null will always be the.
Yeah, but the alternative.
What's that?
The alternative. Is it that his friend or whatever she thinks that
Less. Yeah. So I didn't. So that's not. Yeah. She's asking a very good question. Information I didn't give you. So she's skeptical that he can hit it that far. So that implies that this is going to be left, right-tailed, or two-tailed. Left-tailed, okay, left-tailed. She thinks he cannot hit it that far, and we should have had that in there, okay? So her friend thinks he can't hit it that far. So our null hypothesis, let's see. Shelley, can you tell me what the null hypothesis is? Okay, so the null hypothesis is that his actual mean driving distance is how far? 264.4? Well, that's our sample mean. That's what we do. He hit 25 drives. That's the mean of the ones that he hit. But our hypothesis, what's our hypothesis? That his distance is what? .275. He's claiming he can hit it 275. So, do you see the difference between what this number is and the 275? 275 is our hypothesis about what his true mean is. This is an actual sample mean, right? This is an actual sample mean. See, if that were our hypothesis, then there wouldn't really be a test, because that's what he can do, right? We know he can do that because he just did it in 25 drives. So the null hypothesis is this conjecture before he does the sample. We're saying, can he drive it on average 275 yards? And what is the alternative hypothesis? Whitney.
The mean is less than.
Right. Okay. So now, so his sample mean was less than that. Can we just reject right away? Can we just reject? No, we have to do just because one sample, remember, think about confidence intervals, right? Confidence intervals. Just because one sample was less than 275 doesn't necessarily mean that his mean driving distance is not 275, right? Because if we took lots of samples, some are going to be lower than this and some are going to be higher than this. So just because one sample is lower than this doesn't mean that we're going to reject this fact. What we're asking is it significantly lower? Is it lower enough to reject this, right? Because we know that samples of his drives are going to dance around. They're going to be all over the place. They're not going to be 275 every time. Okay? So our question is 264.4 significantly lower than, at a 5% significant level, is it significantly lower than 275 that we would reject this? Okay? That's the logic of the test. Okay? All right, so now we need criterion for deciding whether to reject the null hypothesis. Okay, and that's on the next page. Questions on the setup or what we've done so far, A and B. Everyone got it? We good? Okay, so now we're going to go on to C. So again, we got our null and our alternative hypotheses. The logic is this sample mean indicating a significantly lower average than 275? If so, we'll reject the null hypothesis. If it's not significantly lower than 275, then we will not reject the null hypothesis. Okay. So this is the idea. A 5%, we want a 5% chance of making a type 1 error. That's what we said, 5% significance level. So what we want then is we want the z-score. This is the critical, this thing right here is the z-score is the critical value. So what z-value gives us a left tail of 0.05? What z-value gives a left tail of 0.05? So this is, you get out your chart for normally distributed. This is halfway between.
No, it is.
So she got negative 1.645. Are you seeing that in your chart? So if you look in your chart, it's exactly halfway between two different z-scores. So this is the critical value, negative 1.645. Okay, so if we, for his, in the sampling distribution of means, he took a sample of size 25, right? So the sampling distribution of means, if his sample falls greater than the z-score of negative 1.645, then we're not going to reject. It's not significantly enough lower to reject. But if his sample mean falls less than negative 1.645 standard deviations below the mean in the sampling distribution, then we're going to reject. And then, so what? We're going to reject, and then there's going to be a 5% chance that we're wrong by rejecting, that he truly does have that, okay? So here's the same thing again. We got our critical value of negative 1.645, rejection region, and the non-rejection region. Okay, so what is the z-score? So remember, think about a sampling distribution for samples of size 25. Population mean of our hypothesis is 275. So do you remember how to get the z-score for a sample mean of 264.4, the z-score in the sampling distribution of samples of size 25? Do you remember how to do it? We've done it. Jason, do you remember how to get that z-score? Almost. So you got the right idea. It's a fraction. So what's going to be in the numerator? $264.4 minus the 275. So we're saying how far below the 275 are we in yards first? So how far are we in yards? But what we want is how far are we below in standard deviations. So what do? We divide by 20 over, remember this? We've done it before. So we're using the sampling distribution for samples of size 25, and we're getting the z-score for a sample mean of 264.4. Crank it up. As soon as you get it, tell me what you got. Negative 2.65. Someone else get that? Is that what you got? And what is that number again? Is that a number of yards? What is that? Number of what? Number of standard deviations. Z-scores are how many standard deviations. So this sample mean, 264.4, is 2.65 standard deviations below a mean of 275. Okay? Are we in the non-rejection region or the rejection region? So now we're comparing the critical value, that's Z alpha. Okay? Our critical value is a Z-score. And then we have the Z-score for our sample. And that's what we're comparing, because this is a Z2. Right? So we're comparing this Z to this Z. Reject or do not reject the null hypothesis? Reject. In fact, it's pretty bad, right? It's not even close to negative 1 points. He's way over here. So that driving average of 264.4 actual is way down here at negative 2.65. So, conclusion, so we reject the null hypothesis. We say there's some significant data here, significant enough for us to say he doesn't drive at 275, okay? Do we know that for sure? No, because we could have made what kind of error? This could be a type 1 error. We could be in this 5% chance that truly he does have a higher driving range than that. But so 5% of the time, this conclusion would be wrong. Basically is what we're saying. It would be a type 1 error. But according to this one sample, we can be 95% confident that no, he does not drive at 275 on average. Okay, so now we're gonna get into some kind of cool stuff. It's like, this is relevant stuff. So I hope you appreciate it. This is cool. The Sunday's online homework will open at 9 a.m. You could do almost more than half of it now. You could work on more than half of it. And I'll see you Wednesday.